Let's talk about arc and arc length. An arc of a circle is any portion of the circumference of the circle. So I'm just going to draw a circle here. Here's the center of the circle. And an arc might be from one point on the circle to the, so this part in blue here, that would represent the arc. The arc length, s, of an arc intercepted by a central angle of theta radians on a circle of radius r is given by the equation s is equal to theta times the radius. So if I were to draw an angle where the vertex is at the center of the circle, basically this equation says that the length of this thing can be measured, and it is equal to the angle theta times whatever the radius of the circle is. So again, the arc length, we denote it with the variable s, is equal to the angle times the radius. Or in shorthand, the equation is s is equal to theta times r. So let's see this equation in action. Example 6 says a wheel has a diameter of 28 inches and an angle of 30 degrees between the spokes. What is the length of the arc S between two adjacent spokes? So if you don't know what a bicycle wheel looks like, it looks something like this. Here's the center, and the spokes are the metal parts. They look something like that. And this is specifically saying that the angle between any two spokes is 30 degrees. So this angle here is 30 degrees. And we know that the diameter of the wheel is 28 inches. Now we have to be careful because the arc length which we are solving for is equal to the angle times the radius. And here we're given the diameter, but the diameter is just 2 times the radius. So to find the radius, we'd cut it in half. And so the radius here would be 14 inches. So if we're solving for s, that's going to be 30 degrees times the radius, which is 14 inches. However, the formula for arc length actually utilizes the angle in radians, because remember, when it's in radians, we don't write this, because if we multiplied the units, this would be degrees times inches, which wouldn't quite make sense. So we actually have to convert the 30 degrees to radians. And I'm going to do that off to the side here. 30 degrees times pi radians. And I'm going to just shorten it to RAD for radians over 180 degrees. So the degrees would cancel out, and then 30 divided by 180, that's going to give us, in the numerator, we'd have pi radians, and then in the denominator, we're going to be left with 6. So pi over 6 radians. So here I'm just going to write pi over 6 in my formula. And if you multiply that, you would get s is equal to 14 pi over 6 inches. And since this is an application problem, it'd make a little bit more sense to throw this into our calculator and find that this is equal to approximately 7.33 inches. So if we're looking at the bicycle wheel, that tells us that this length here, this arc length, that length is 7.33 inches. So really quickly, just as a quick reminder, when we defined arc length up here, the arc length is equal to the angle times the radius, but the angle has to be in radians. So just be careful about that when you're thinking about the angle in these types of problems. Example 7 says the distance between Los Angeles and New York City is 4,505 miles. Find the central angle that intercepts an arc of 4,505 miles on the surface of the Earth if the radius of the Earth is 3,959 miles. So here's the Earth. It is circular like that. And let's say here is Los Angeles. And here is New York City. Now, I probably haven't drawn this correctly to scale, but whatever. So here's the center of the Earth, and we know that the arc length, basically, we know that the distance between Los Angeles and New York City is 4,505 miles. And we also know that the radius of the Earth, so if I drew my angle here, we know that the radius is the distance from here to the center, and that is 3,959 miles. And so if we think about the arc length formula, we have S is equal to theta times R. Now, when you're doing algebra like this, you always want to ask yourself, what values in our equation do we know, and which ones do we not know? And it says find the central angle, so that's probably going to mean that we don't know what theta is, which matches our picture, and we should know the other values, which we do. We know that the arc length is 4,505 miles, and we know that the radius is 3,959 miles. So if we do some algebra and we divide both sides by 3,959, we get that theta is equal to 4,505 divided by 3,959, which is approximately, and I'm rounding this to 2 decimal places, 1.14 radians. So that is the amount of rotation needed to get from LA to New York City. Let's talk about area of a sector now. So the area A of a sector with central angle theta in radians in a circle of radius r is given by the formula A equals theta times the radius squared divided by 2. Why is this important? Because if you have a sector of a circle, you might want to calculate the area of that portion of the circle. Why? Because pizza is circular, and I absolutely need to know that the area of my slice of pizza is bigger than the area of my friend's slice of pizza, because I need to be getting more pizza than them, right? Example 8 says, a sprinkler waters a circular field with radius 200 feet. So let's go ahead and draw my circle. Here's the center, and we know that the radius is 200 feet. And it says in 3 hours, it will water a sector with a central angle of pi over 8. So this angle is pi over 8. It's not to scale, but that means that I'll draw it in blue. So the amount of water that the sprinkler gives off is in that blue. So we want to basically find the area of that sector, and we want to figure out how much area of the field has been watered. So really, that is just a matter of plugging things into the formula. We know that the area is equal to the angle in radians times the radius squared over 2. So that's going to end up being pi over 8. which we don't have to convert since that's already in radians. And then the radius is 200 squared, and then dividing that by 2. And if you threw that into your calculator, you would get that the area is approximately 7,854 feet squared. And so that's the amount of field that has been watered.